We are now going to look at a whole lot of different forces that when we're drawing force diagrams or free body diagrams, we're going to need to be aware of on bodies around us. The first one is the force of weight. Weight is the gravitational force that the Earth exerts on any object on or near its surface. We're going to symbolize that with a capital F and subscript G, because it is the force due to gravity or gravitational acceleration. It is measured in the unit newtons. Gravitational force is always equal to the mass of the object multiplied by gravitational acceleration, and gravitational acceleration is going to be 9,8 meters per second squared. So if, for example, we've got something that has a mass of 100 kilograms, Fg is going to be equal to 100 times by 9,8, mass in kilograms multiplied by 9,8, and you land up with 9,800 newtons is the weight of that object. So weight and mass are not the same thing. The weight of an object is dependent on the planet which it is near, and 9,8 is for Earth. If you're working on Jupiter, it's about 10 times more. If you're working on the moon, it's about 6 times less. So each different planet has got a different gravitational acceleration. And we looked at this when we were looking at Newton's universal law of gravitation. So if we're looking at a book lying on a table, it's got a gravitational force acting downwards, weight, and it has the force of the table, or the normal force. Remember, in the last video we called that the normal force. It acts at 90 degrees to the surface. The force that opposes the gravitational force by an object is going to be the normal force. In other words, that's the reason the book stands still. Otherwise the book would just go straight through the table. So what is the normal force by definition? It is a perpendicular force, always at 90 degrees to the surface, exerted by a surface on an object that it is in contact with. In other words, it is the force that stops the object from going through whatever it is sitting on. Since the book is not moving, all those forces are going to be equal to one another, and the resultant force is still 0 on that book. Friction is another force. It cannot cause acceleration. In other words, you can't suddenly, just due to friction, get propelled forward. So let's think of it. You're sitting on a rough, stony path, and suddenly the path shoots you forward. No, that's not going to happen. So it doesn't cause acceleration. But if you try and wriggle forward on your backside on a rough, stony path, you will find that you will be inhibited or slowed down by the force of friction. A frictional force is the force that opposes the motion. So there has to be a motion to oppose. If there's no motion, friction doesn't come into play of an object, and it always acts parallel to the surface with which the object is in contact. You get two different types of friction. One is called static friction, and it is a force that exists when there's no movement. In other words, it just holds something in its position. And we go back to the picture where we had the brick sitting there on the slope. If it's standing still, that brick, it has got static friction that is holding it from sliding down that hill. The maximum static friction is the frictional force just before that object would begin to move, because the static friction has been overcome. So eventually you reach a point where the slope can no longer keep the brick there, and at that point the downward force is going to override friction and static friction would be overcome. There's still going to be friction though. There's something going to oppose the motion, and that is dynamic friction, and it is the force that exists if a body is moving. Dynamic means moving, static means still. So, friction in our lives, what's the use of it? If there was no friction, one of the things we can start imagining is, what if we were sitting on an ice rink? If you're on an ice rink and you lean against the barrier, so here we have a barrier and here we've got a person and they're on ice skates. Okay, smiling. and now they push against that barrier, what's going to happen is they're just going to shoot out and they're going to land bloop on their face. Why? Because there's no friction holding them where they are. In fact, if you haven't got ice skates on and you try to walk on ice, you will find that you will slip and slide. So let's just look at what happens when a guy does try and walk on ice. Now, the reason we don't slip and slide like that all the time is because friction actually helps us to stay stable. We get a resistant force and we're able to walk forwards because of the frictional force that holds us in place. Friction is used in a great number of mechanical and mechanisms in order to resist motion and to provide grip in what we are doing. We need to be able to do some calculations with friction. A 4 kilogram block is at rest on a rough horizontal surface. The coefficient of static friction. Now, this coefficient of static friction tells me how much friction a certain surface can exert. So let's say I had a pebbly surface, the number would be big. If I was on ice, the number would be very small. So it says here, establish the maximum static frictional force acting on the block. So the maximum frictional force will always be the coefficient of static friction, which I abbreviate with a mu sign, and just draw that again like that, and the Fn, which is our normal force. Remember, the normal force is always exactly equal to the weight, but in the opposite direction. So, as a result, that normal force is going to be equal to mass times gravitational acceleration. It's a 4 kilogram block, mass, times gravitational acceleration on Earth, 9,8, multiplied by the coefficient of static friction on that particular surface. And I then land up with a force of friction, maximum frictional force on that particular surface for that particular object. What's important to realize is that heavier objects will have greater friction, lighter objects less. Rougher surfaces would have greater friction, smoother surfaces less.